Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Hi everyone, my name is Faisal Khalil and welcome in another professional DevOps technologies tutorial. In previous tutorial, we were discussing Docker and its use case, concept, how Docker evolved, what is the history, what value it's added, and why people using it, and some other technologies built on top of it, some virtualization concept, and all those matters. We have discussed in detail conceptual understanding of the Docker. Now later on, what we can do is that today's agenda is installation, and these are the installation steps, which are just official. Um, these are the official, let's say like that, guidelines from the Docker, how to install Docker. Then we are we are going to discuss some basic commands, how to create Docker, how to run Docker, how to check the state of Docker, how to check the images, what is the Docker pull, how we can pull something from the Docker, which is the Docker repository in case, and how we can start, stop, and restart the Docker. So what is the image and what is the Docker? There's a big difference between these two. Normally people get confused in them. What are the major types or and categories of the Docker, like operating based system and Docker, and application based Docker? What is the use case of both? Why people use them? Then there are some intrinsic, very important concept, like when you create Docker, it automatically creates a process ID. This process ID is created for the user. It automatically creates a user. And for OS-based system, it's not creating it automatically. There is a small difference between these two. So yeah, a difference between detached and interactive mode of Docker, and the important concept, like how you can run actually Docker, and what happens if you stop the Docker, and how you can exit Docker, and what is the uh, difference between Docker exit and Docker PQ to get out of Docker. So yeah, these are the things actually right now. It is very important. Normally, you might have heard that it is always, it is always recommended that you always use Docker PQ rather than Docker exit. There is there is main difference between these two, why these things are used. Let's first go to the virtual machine actually, and we can start any virtual machine, and then starting this machine, and then start running the Docker actually, installing the Docker process, and then we'll see that one by one we'll run these commands and Docker will be installed. Then this is the virtual machine actually. Yeah, let's see how it does. Okay, there you go. So here it comes, and our virtual machine is going to start soon. Okay. We give password. So first things first, we are recommended to do this, but it's not a mandatory step. First thing first is that we do that. So why we do that? There is no actually, a hardcore explanation of that, because this is what builder of Docker or the people who create the Docker, they need to do some like certification installation for the security purpose, and then you need to add GCP key always. We need to create another directory here with the name of key string, and then we'll use that to create the GPG keys. This is just for security purpose, and this steps are given by official Docker, right? So there is a docker.list in the source.list, and you create this or write this to the device.null. This is the requirement, and then you have created something, which means that you need to update your repositories where you add keys, you add new free things or get updated. After things get updated, you are just good to run this command here. There is some problem here. Sudo apt docker compose plugin. Okay, let me just see what is the problem. Okay, look, I have checked on the Google, and different sources are saying different things, and I found here this discrepancy, which means that rather than adding keyring into keyring, you need to have another subfolder of docker archive keyring.gnp. So I don't know if just changing the name of the key, uh, the name of the key it's searching for maybe change in the backend, and that's why just docker.gpg rather than we just change the name of the key file here. The rest everything remains same. And now let's install one by one docker ce first, and that runs. And then let's install docker c cli after that, and then docker compose and plugin. So these are the different actually let's say like that, they are different files. There are different modules to run docker completely. I guess that it automatically has installed some of the docker compose and other stuff automatically, but let's see. We can even run this command again, whole command, and it's automatically say that it's already installed. Okay, then now actually we can run this command here to check that, well, it's automatically install everything here, and it looks like that now we have installed. The only thing was that the script which we have ordered in the source list.d, this is apt sources, where the apt search for the packages and repositories, that is not available, and somehow it automatically searches for jpg key with this name rather than this name. That was the apparently problem. And now let's test it, if it is installed. Hello world. Now the problem always is that you need to do this always. Hello world latest locally. It says that we didn't found this image. So we're going to actually now that's that. Now there are some core concepts we need to learn here. Well, Java. Now we need to learn some concept here, which means that if I run command docker images, always sudo, right? Which is my master VM is in the sudo file, and then I need root user, and that's why it's doing that. And now you can see that here, hello world is the new image, tag is the latest, this is the ID, this is the unique ID for everything, and how this image is created. Now we haven't created anything, we are going to pull this. And if I show you, so this is apparently, if I show you, is the main repository of Docker I have shown in the previous tutorial, and it's always find something local. If there is nothing available local, it's trying to pull this from here. You can even also run the command, for example, docker pull Ubuntu, and then it's going to pull up the image of the Ubuntu 24 focal, this novel, and will store it locally. And next time, then when you're trying to create Docker with Docker create, and it's going to create a Docker. Very simple. So if I say Docker pull Ubuntu, and so it's the same problem. And then it's trying to download. This is a complete window. How Docker works, we have discussed this in detail, that how Docker really works. And now if I run Docker images and then it's gonna show me that, well, there is one image available. So what is the image? Image is nothing, but the community has created a very easy to use lot of different images. Sometimes it is only window, like if I search here Ubuntu or any operating system, then this is a Docker official image of that window. If, for example, I search Nginx, then this is the Nginx, right? What is the Nginx? This is the server for many web server deployment. Anything you write, so there are like thousands of images, like 10,000 entries for one search is available. You can imagine that how nowadays it is easy. Nowadays, this is the practice in the industry, that whatever software, whatever thing you build, you always create a Docker for it. Why? So that people could easily manage that software and use them as per their need. And then there is no discrepancy, regardless if your image is created in any part of the world. When you push it or pull it on this hub, then anybody can pull it, and he's going to see exact same functionality of that software what is created. Normally it is not possible. Normally, for example, I am installing a lot of Python 3, Python 4, then some libraries, some other stuff, and then I'm running something, and it's on my laptop. And if I copy paste and give it to somebody else, he's not gonna run this all very smoothly. Why? Because maybe he's using different window. But Docker technology, as we have discussed in detail in the previous tutorial, that they are using the intrinsic, they are using the underlying resources of the virtual machine, but on the top they have another layer where they operationalize and create another partial operating system, which is very similar to operating system, whatever operating system we are using. And it is very lightweight. It is some MBs, and it is matter of second to start and restart. And this is very handy and revolution in the industry. Having that said, so for example, next thing is Now we want to create a Docker, and we also want to get into this Docker while, and we want to create a Docker with Ubuntu image. And for this we have this tag, and it's always, um, for example, if I run docker run is always a command to create a new Docker. It mean that I want to create interactive mode. Yeah, great. Then there is another concept of port mapping. I will discuss this concept shortly. Let us add this concept into the because this is very important concept actually, and it's called port mapping. Mapping out port forwarding in Docker. Keep in mind that Docker IP and ports are never accessible from outside world, which means you always have to map your ports with port. You have to map your ports from host computer to Docker for any sort of traffic. Having that said, we'll discuss this later. So now, very important concept many people don't know, and it's always very confusing, that what is difference between the images and Docker. Let me first create a Docker container. We have pulled the image, which is the Ubuntu. Now let me just create, for example, I want, okay, okay. So that's the ID of the image I want to use. And then I'm saying that I want to use bash, and this is second time sudo, always sudo. Great. When we run this command, what happens is that now we have created a Docker, we have created a container. So let's see, for example, if I now use Docker ps, this is the sucker Docker ps, no, sorry. So for example, now I want to get out of this Docker. I always write control PQ, and I am now out of the Docker. And it is always recommended that you use the same command. There is a reason behind it. I will discuss it shortly. But now, for example, if I run Docker ps, it's going to show me that that was the name of Docker. Let's make it a little bigger to see it more easily. It's saying that this is the container. This container is running on that image. This image we can confirm. Where this image? God. Where this image? This image is the same what we are using here. One image we have created as a hello world earlier, right? And now you can see that a minute ago uh, there is no port at all, because we haven't done any port mapping or something like that. The name, it is automatically given to this, and this is now container. This is the image, and this is the container. Now it's a very important concept here. What is the difference between image and a Docker container? Container is similar to a laptop. It is just a laptop let's say like that, a virtual laptop or a virtual containerized space, which is meant to act like a laptop, let's say like that. Very simple layman example. You buy a laptop, what you do, you have to do, you have to install operating system in it. What is the operating system? Window, like Windows 10, Windows 11, and whatever other Mac 1, Mac 2, or Ubuntu, CentOS, or whatever. Now, for example, this is the window in shape of image. This is the window in shape of image. And with Docker run IT, what we have done, we have actually installed a window in this container, which is nothing but a laptop, a virtual laptop, which is very advanced, lightweight, and can expand and can shrink. So this is the concept behind that, which is that's how we can easily understand this. And we can also run Docker stats. Well, Docker stats give you a very neat way of what it is. It says that how much memory is using. It's barely using nothing. It's barely using no memory, very minimal. Block is your hard disk memory. It's using net IO input output internet KBs traffic. It's using memory is barely nothing. A lot of memory available for him. This is the virtual machine memory, and out of it, it is the process ID is equal to 1, which means that this process ID is root user ID, right? And yeah, context is cancelled. That's great. And for example, if I uh, yeah, that's that. What else? Okay, great. So now we need to see that how container stops. The main difference here that if I say here docker ps sudo docker ps, then it's showing only running container. If I stop that container and I have this ID of the container which I can copy, and I can run sudo docker and stop this ID, it's going to stop the container completely. And now if I stop it, definitely it's not going to show anything. Sudo docker ps, and it's showing nothing. Why it's so? Because docker ps is only showing running container. If I modify that command and I say docker all, then it's showing me everything when it is exited and when it is, which mean it is created and everything. So that's docker stop, docker start. So for some reason, if you install something and you want to restart, you can just supply a docker um, instead of stop, you can just say docker restart.